Hi y'all! Welcome to some real-world quadratic problems. Let's go ahead and tackle this first one. You throw a stone from a height of 16 feet with an upward velocity of 32 feet per second. The function h equals negative 16t squared plus 32t plus 16 gives the height h of the stone after t seconds. When does the stone land in the water? First of all, let's notice some interesting things here. It says the stone starts from a height of 16 feet. And notice that the 16 is located here. That is always true. That makes sense because when time equals 0, if I plugged in 0 for time, you would see that you get a height, the zeros disappeared, of 16. So that is true. That number right here represents the initial height of the stone. What else do we notice here? Oh, the upward velocity of 32 feet per second. That's almost like how fast you're throwing it. And notice that this right here is positive 32. So this would be your initial velocity. And notice that this is a negative, and that totally makes sense when we're looking at this real-world parabola. You've got something like that. Okay, what do you think that the y-axis stands for? Well, I'll give you a hint. This is 16. I'll give you another hint. This is 16 feet. So this on the y-axis is going to be height. Now, how about over here? What is this x-axis going to be? Well, this is going to be time. And the question is asking, when does the stone land in the water? So here's the stone being thrown up, and then boom, it hits the water right here. So what we really care about is this coordinate right here. Well, what do those coordinates look like? We've got something, comma, something. This x value, remember x is going to be time, and our y value is going to be h for height. Well, what do we care about when it says when? When does the stone land in the water? Well, what we care about is this value right here. So what I'm going to do is I'm going to open up Desmos. And we're going to graph this equation, negative 16t squared plus 32t plus 16, and we're going to find that coordinate. So I want you to kind of practice this with me. All right, I want to keep those. All right, so going over to Desmos here, just desmos.com, click on Graphing Calculator. And I'm going to do a negative 16, and I'm going to go to my keyboard, and I'm going to do an x squared, and then plus 32x plus 16. Notice that I had to use x instead of t, but that's just because how Desmos doesn't let me do that. Notice, folks, that we do start at 16. And then you've got your graph going up from 16, and then it hits the water right here. So what does this coordinate mean? 2.414, comma 0. 2.414, comma 0. 2.414, comma 0. Let me write that down now that I'll never forget. This is going to be a 2.414, comma 0. Well, that means at 2.414 seconds, my height is 0, meaning it's on the ground, or in this case, in the water. So our answer is going to be 2.414 seconds. What's our takeaway from the slide? If it asks you in the problem to find when the ball or the person or the dog that you throw up, anything that you throw up, we call that a projectile. Anything that you toss up, and I say, when does it land on the ground, you are looking for this point right here. All right, let's move forward. A tennis ball is tossed vertically upward according to the height of the following. So interesting, this would be our upward velocity. It's starting at 5 feet. So here's the question, when will the ball hit the ground? Well, let's go back to Desmos, and we're just going to change that equation that we had. It's pretty close, but let's go back. Give me a second, I'm just kind of wiggling my computer. All right, so here I go back to Desmos. I'm going to change this to a 21, and then I'm changing this to a 5. So when does was it a ball, a tennis ball? Yeah, when does it hit the ground? Well, that's going to be right here, 1.518 seconds. 1.518 seconds. 1.518 seconds. All right, so this will be 1.518 seconds. At what time will the ball be at its max height? Well, where is that located? My max height, of course, is going to be at the maximum, at the vertex of my parabola. And this would be the time when it hits the max. And then if I'm taking my y coordinate, that would be the actual height that the ball got to. Since this one's asking for the time, we're going to take the x coordinate. So let's go back to Desmos and see what answer we've got there. Okay, here's my max, and it's going to be 0.656, 11.891. Now let's go back to this slide and write that down. Okay, so that was 0.656, 11.891. So at what time, which one tells me time? It is the first value, the x coordinate, because the x value is time. So my answer is a 0.656, and if it doesn't tell you in the problem, it is implied that it's seconds. All right, let's tackle the next problem. How high will the ball be at its max height? Well, that would be this coordinate right here, because that is the height. It's the y value. Remember, the y value here is height. So you're going to take that y value right there, 11.891. 11.891, and that's going to be the maximum height of the tennis ball. How high was the tennis ball at the exact moment the ball left the player's hand? Well, what time is that? That's when time is equal to 0. So we're just going to go ahead and plug 0 in. And you should already know this answer, but let's go ahead and do that. So we get a negative 16 0 squared plus 21 times 0 plus 5. Well, all these things right here just become a 0 plus 5. We know 0 plus 5 is 5. So height is equal to 5 feet. And that kind of makes sense because most people are around that tall. But you could have also just looked at that value right here and said the tennis ball started at 5 feet, and that's when it leaves the player's hand. What was the height of the ball at 1 second? Well, how do we do this? Well, this is basically saying what is h when time is equal to 1? Well, all we're going to do is just find h by plugging in 1 into this equation. So I just pick up my calculator and I do that, and I get 10 exactly. So the height of the ball at 1 second is, the math I do is just plugging 1 in, and I get a height of 10 feet. All right, let's move on from this problem. A chicken, a reasonable thing to toss, your projectile. A chicken is tossed vertically upward according to the height of h equals negative 16t squared plus 48t plus 3. How high is the chicken at 1 second? Well, what do we do here? We plug in. So this is going to be a negative 16, 1 squared, plus 48 times 1 plus 3. So let me do that really quickly. Though I think I can do this one in my head. I get 35 feet. Next one says, when will the chicken hit the ground? So I'm looking for this vertex right here, and it says when. So remember, it's time, comma, height. So I'm looking for the x value. All right, so let me go ahead and go to Desmos and graph this. All right, so I took some time to graph this. This is our new equation right here. And we're looking for when it hit the ground. So that's going to be the time 3.061. 3.061. 3.061 seconds. All right, last question says find the time when the chicken reaches its max height and give the max height. Well, that's going to ask us for this coordinate right here. That's going to give us the time will be the x coordinate and the height will be the y. So let's go back to Desmos. All right, so this coordinate is, whoa, way up high. It's going to be, the time is 1.5 seconds, and it's going to be a max height of 39. 1.5 seconds, 39. I don't know what happened there. There we go. At 1.5 seconds, the chicken is at its max height of 39 feet. All right, we've nailed it. Here's the summary. How would you figure out how high the projectile is at t equals 4 seconds? There's no equation, so this is just me generalizing what you do on these types of problems. So in this particular case, you're just going to plug t equals 4 into the equation, and that just solves you for h. When will the projectile hit the ground? You are looking for this point right here, and remember it is going to be time, comma, height. So you are looking for this x coordinate right here. Number 3, find the time when the projectile reaches its max height and give the max height. Well, in this case, you're talking about this point right here, and that would be time, comma, height again. So when it's asking you for its max height, it's the y value. If it's asking you for find the time, it would be the x value. All right, last question says, at what height did the projectile start? Remember, everything is being written as h equals ax squared plus bx plus c. It will always be this value right here. So for example, this chicken started at 3 feet, and this tennis ball started at 5 feet. All right, ladies and gentlemen, thank you so much for watching. I hope you have a beautiful day full of lots of giggles and joy. Thanks.